So cathode ray oscilloscope, you would have seen in electronics lab, which will display the signals. So it is a instrument which is going to show you the amplitude of any signal with the function of time. So it has the cathode ray oscilloscope has three elements. One is the amplifiers, power supply circuits, and the cathode ray tube. This is the old TV which we had in the olden days. It uses the CRT. Now, so let us see the construction of the cathode ray oscilloscope. You will be having a glass tube, okay, and then you will have a filament. After the filament, you will be having a cathode which is going to generate the electrons. Then the control grid to control the electrons, and you have two anodes here. One anode is for to focus the electron in the correct path. The other anode is to accelerate it. Okay. Now you have a deflection plate. One is horizontal deflection plate to show you the correct time period. The other one is vertical deflection plates to show you the amplitude. Then you will have a coating of aquadag coating which will trap your escaping electrons back to the grid. And then you will have the screen which is coated with the phosphor. Actually, according to the type of the screen, you will be having the CRT for various purposes. Okay. So after this, we are going to see the signal which is given to the CRT tubes. That is, the signal will be given to a vertical attenuator. From that, it is given to a vertical amplifier, then to the vertical deflection plates. Then you will have a synchronization. So part of the signal is given to a sawtooth generator, and then it is given to a horizontal amplifier, then it is given to the horizontal plates. So to trigger the cathode, you need to have a power supply. So the cathode and the anode is given with the high voltage power supply circuits through the resistance like this. So this is your construction of your cathode ray oscilloscope and the beam. Okay. So the center point will be always when you switch on it, when you are not giving the signals, you will be getting a green color dot in the center of the CRO. So that is what I have shown you here. Now, after this we will see one by one and we will see how it is working. Okay, so first one is horizontal and vertical amplifiers. So I'm going to give a sine wave here. You can give triangular, whatever it may be. So for better understanding, I'm going to give a sine wave. So the sine wave is given to the vertical attenuator, which is given to your amplifier, and in turn it is given to the deflection plate. So from the vertical attenuator, it is going on to the deflection plate through the vertical amplifier. That is what I have given here. And then after that, the sine wave is given to the synchronization, and then the sawtooth generator will convert the sine wave into sawtooth wave. Then it is given to a horizontal to have it in the time domain. So vertical for the amplitude and horizontal deflection plate for the time. After this, we are going to have the power supply circuit. So the power supply circuit, this is provided to give you the supplies to the cathode and the anode. Okay. So it is provided. Why we are giving the supply? To generate the electron beam. Okay. To trigger it. So this is regarding your power supply circuit. Now we are coming to the center part. So in this cathode ray tube, we are going to have three parts. One is your electron gun, one is your horizontal deflection plate, the other one is vertical deflection plate. So electron gun consists of cathode, anode, grid, filament, etc. Then horizontal and vertical deflection plate. Then your gas envelope. Okay. So this is the heart of the oscilloscope. Because this one will show you the picture, and the beam will be generated from this also. So this is the heart of the electron. So we will see all the three parts one by one. First one is glass envelope and screen. So you know this is your glass envelope. We are having the coating, as I told you, it is used for capturing the secondary emitted electrons. Okay, and then we will have the screen. It is also coated. If it is coated with zinc orthosilicate, which is green in color, it is CRO. It is used in CRO. If it is a calcium tungstate, blue in color, it is used in photography. I'm sorry. And then if it is zinc sulfide or zinc cadmium sulfide, it is used in white television. Okay, so this is regarding a glass envelope screen. Then we are moving on to the electron gun. Electron gun consists of cathode ray grid, focusing anode and accelerating anode. As I told you, we are having two types of anode. So this grid consists of the cathode and the filament, which is maintained at the negative potential. Okay, this will be accelerated. And the anode 1 and anode 2. Anode 1 will be maintained at positive potential, while anode 2 will be maintained at higher positive potential than the previous anode. So this is, one is to focus the beam, the other one is to accelerate the electron beam. Okay, so it will converse the electron beam through the deflection plates. So this is regarding your electron gun. So grid, focusing anode and accelerating anode. Then we moving on to the deflection plates. So you know that the power supply is given. The deflection plates, what happens in the sense, when there is no input is given, you will get a dot like this. So I've given you a screen like structure at below to show you the waveform generator. So when the no voltage is applied, a dot is shown. The dot is the green color I have shown you here. Now, let us consider, I'm going to give you a supply. So, the amplitude is given through this vertical, and the time domain will be given through the horizontal. So, accordingly, the waveform beam will be deflected. So, the positives from 0, it is given to the higher potential. Then, if the beam is deflected below, okay, like this, it is travel to the lower potential. Likewise, for both the positive and the negative cycle, it is the waveform will be generated. So this is regarding your CRO. With this